Hello students, thanks for tuning in. This is part 2 of EQ 3-5. We're going to be looking at what are the causes of the major biomes on the planet. Previously you looked at what are the characteristics of them. Now we're trying to look at the reasons why they are and where they are. So the first is incoming solar intensity. Where is the solar intensity the greatest? Where is it the least? Label these locations in the diagram. The solar intensity is going to be greatest wherever the sun rays are coming in most perpendicular to the surface of the Earth. And we see that happening here. So this is going to be most intense. And at the areas where we see this angle being the least, that's where it's going to be least intense. In fact, the angle here is 0 degrees. So we could say that this is least intense. In terms of the sunlight striking the surface of the Earth, here at the very top where the person's standing, the rays are actually going parallel to the surface. So what you would see if you were standing there and looking out at the sky is you would see the sun just hovering on the horizon. The sun would not actually rise, or it would not actually be able to see it. You would just see the glow right below the horizon. And the same could be said for this location on the bottom, that's where the intensity is the least. So we can also take this and move it down here. Let's see if I can do this. Oh, how cool is that? Okay. All right. There's another way of looking at this down here, which is same thing, but just looking at it from a different perspective. The sunlight's coming in, and when it's coming in directly perpendicular to the surface, that light is going to be concentrated into a given space. As the sunlight comes in at a greater angle, the light ends up getting spread out over a wider space of land. So it's not that the light from the sun has changed, it's just that it's getting spread out over a bigger area. The sun is still burning just as bright as ever. So for that reason, we can see that the light is more intense when it's coming in perpendicular. So for the explanation part, when the sun is directly overhead, it causes, I'd like you to put this into your own words, what does it cause to change about the light? And you can also write a similar thing for what happens when the sun is at an angle. So go ahead and pause and think about how you would explain that to yourself. And if you want some more direction on this, there is the portion in your book. I'll list the page on, let's see here. I'll list the page number in the Neo. Okay, the next part of this is, how does the Earth's tilt relate to the seasons? In the diagram below, label where the Earth is on the first day of summer, fall, winter, and spring. So this relates to what we just saw, and we know that some biomes will experience greater variation throughout the year than others. So we have to I should specify here, on the first day of summer for the northern hemisphere, because the seasons are flipped between the northern and southern hemisphere. When we have our winter, they have their summer, and vice versa. So our summer is going to be here, where the Earth is the axis is tilted towards the sun, which means half a year later is when we have the first day of winter. And you can guess now where to put spring and fall. So we use the word solstice when we're talking about the first day of summer and the first day of winter. So if you could define that and label those two locations above, this would be summer solstice. And I didn't have you list which day that is, but this is usually around June 21st. And then define equinox. So these are the days of equal day and equal night. And I will, I guess, take this moment to also say that solstice is the day of the longest day of the year, which is the first day of summer, and the longest night of the year, or the shortest day of the year, which is the first day of winter. So if we fast forward 3 seasons from the first day of summer, we get to the first day of fall, which is September 21st. Which locations on Earth would you expect to have the greatest variation in seasons? Which places would you expect to have the least variation in seasons? Explain. So, when we think about places that are farthest from the pole, we can see that here, the North Pole actually will not see the sun, even as the Earth rotates around. Still, this North Pole location will be on the back side of the Earth. And so, compare that to in the summertime, when as the Earth rotates, this location of the North Pole is constantly being bathed by sunlight. Sunlight that's not very intense, but it is still sunlight nonetheless. So you can describe how we see maximum variation in seasons at the poles. And thinking about extremes, if that's the maximum, where would you have the least? It can help to think about extremes as being, well, where are you farthest from the poles? And you might conclude that that would be along the equator. At the equator, the seasons are very mild. In fact, in a lot of ways, you could say they don't have seasons at all in some way, because if the seasons are flipped between the northern hemisphere and the southern hemisphere, what does that mean for the area right in between? If we're having winter in the north and it's summer in the south, what is it in the middle? And so the reality is they have very little change in their weather throughout the year, because they're always, that's one way of looking at it. And you could also say that they every day experience equal day and equal night. I won't go into more details about that. I don't want to confuse you or try to confuse myself. All right. Now the third part of this is looking at what's happening at the equator that gives us the type of weather that we have there. So first thing I'm going to ask you to do is draw the equator in this photo of Earth from space taken from satellites. So you can see from our diagram up here, or perhaps the one further up, that the equator is going through South America, just a little bit above these points here. So that would correspond to somewhere like, let's see here, then if I want to move it, I think I can click on that, right? How do I move that line? Okay, well, you know what? I was pretty close, though, the first time. So, no need to move it. What biomes are we going through at that point? So this here is one of the most famous rainforests on the planet, called the Amazon. This is a rainforest in Central Africa. The Republic of Congo is one country that rainforest exists in. And this whole area here, the Southeast Pacific, is where we have many islands, lots of rain. Indonesia is the largest country in that region. And so if we also look at this photo, we can see that up above it we have deserts. This is the largest desert in the world, the Sahara. Here is another famous desert in the world. We call it the Australian outback. We have the Mexican desert here. We have some desert down here in southern African continent. We have a little bit of desert down here. So the point is, of course, here's the Middle East, big desert area. The point is that these deserts are slightly above the equator and slightly below the equator. And it all comes down to physics. So let's take a look at that in this diagram. So we already established that the equator is getting the most intense sunlight, at least on average throughout the year. The way the Earth is shown in this diagram, it does not have a tilt, but it's showing it as just being perpendicular to the incoming sunlight. So this is where it's going to be the hottest. And yes, so this is the hottest. I asked you to label the rainforest. So we have here rainforest, and up here we have deserts, and down here we have desert. So here it's going to be warm because of all the sunlight. When the land gets warm from the sun, it heats the air above it. That warm air rises. But as warm air rises and moves towards the poles, things happen. Warm air rises and cools. When air cools, it releases the moisture that it's holding in the form of water vapor. It's holding the moisture as water vapor. That water vapor condenses into little droplets of liquid, which comes down as rain. So it cools, causing the water vapor to condense into rain. And we can also say the word rain droplets if you want. So to recap that point, the air rises above the equator because the land is getting warmed by the sun. As it's rising, it's bringing with it water vapor. As it rises, it's cooling, and that causes the water vapor to condense into rain droplets. Now, air that comes up has to come down somewhere. And that creates a cycle. So the air rises along here, and then as it rises, it comes over here and comes back down. And over here it comes back down. When air is coming down, it is heated. So let's look at it this way. The air now cools because it's lost all this moisture, you could say, and well, it's been rising and cooling in the process. And this cooler air now is descending or falling back towards Earth. And when air comes down to lower elevations, it's actually getting compressed because the air pressure is higher closer to the ground. So it cools and descends at lower latitudes. It becomes hotter as it's sinking. Or we can say as it descends. Let's use a more technical term. As it descends. And it's also dry air because the moisture that it was holding has already come out as rain. So we get these deserts now above the equator and below the equator. This pocket here of circulating air this way has a name, and we call it a cell. This particular one is called a Hadley cell. It's the name for the one that occurs over the equator. But they also occur further up. It's kind of like, reminds me of gears a little bit, where here we have the pattern going around counterclockwise, and that's going to cause the next cell to go around clockwise. Because in the middle, the air has to be moving in a consistent way for each of the two cycles. So we end up getting another type of these convection cells at higher latitudes where the rain is being formed from air rising, and as the air rises it cools and releases the moisture as rain. And so that's what we're seeing at our temperate range.